back. In last lecture we talked about the seismic waves, and most important part which we discussed was the frequency of seismic waves. Different type of the frequencies are generated during an earthquake. So basically the body waves are the higher frequency waves ranging from zero point 0.5 to 20 hertz, whereas the surface waves are low frequency waves having the frequencies which are less than 1.0 hertz. Okay, so the higher frequency waves dies out very faster, and the low frequency waves will travel far distance. Okay, so that what we were talking about, that the shaking will result by the high frequency waves, if you are having, will cause shorter buildings to vibrate, and the low frequency waves will cause higher building to vibrate. Okay, so if it is this shaking vibration cause that usually is been important, because that will cause the damage to the main civil structures and all that. So this is important, that near epicenter both the frequency, because high and low frequencies will be generated, and both types of buildings like taller and shorter buildings will be expected to damage. Okay, whereas the increasing distance, the high frequency waves, as we were talking about, that they will die out, so it will not affect the shorter buildings, but the taller buildings, because the low frequency waves will have tendency to travel far distance, will damage the taller buildings also. So this was the last part which we discussed. Now the another part which is important of the seismic interior or the earthquake related portion is the magnitude. Okay, so we'll talk about very quickly about the different type of magnitude scales and all that, and what are the other methods which are available to measure the earthquake. So in short, we have two types of methods which are available, and the intensity scale, and then we are having, so basically intensity is the representation of the ground shaking and then related damage at the particular area. Okay, and so during an earthquake you will have the damage which will be seen or experienced by an area. So depending on the damage, how it varies from the epicentral area, if you move away from the epicentral area, depending on that, this intensity maps are generated. Okay, and they are represented mainly in form of like intensity scale in a Roman letter, mainly from 1 to 12. Okay, so this is what this is one of the scale which is known as modified Mercalli scale, or MMS scale is there. So here everything is based on the effects. Okay, the pattern, the nature of damage and all that, whereas the magnitude where is representation of the amount of seismic energy released during an earthquake. Okay, and this has a representation again. We have very briefly we discussed about this, that how we can measure the earthquake if you are having the arrival of P and S waves and the amplitude of P and S waves. If you are having that, so based on that you can talk about the magnitude. What is the magnitude of that? The representation of this is given in numbers from 1 to like up to 9.5. The largest magnitude earthquake recorded after having the instrumentation and all that, or recorded until now in the history of earth, is 9.5 magnitude. Beyond that we have not recorded such a large magnitude earthquake, and that 9.5 magnitude earthquake was the Chilean earthquake of 1960. So the main difference, if you look at, so the intensity is the representation of the effect, that is the ground shaking and damage related, and magnitude is the representation of amount of seismic energy released by an earthquake. Okay, and the other point which is the difference between the intensity and the magnitude scale is that intensity scale is represented in Roman letter from 1 to 12, and again the magnitude scale is also from 1 to 10. Okay, but this is in numbers. Okay, this is 1 2 3 4 like that. So if you go back into the history of the development, because earlier we never had instruments to measure the energy which was been released at the time of an earthquake. So the first seismograph which came in was been invented by Chinese. Okay, almost like 2000 years back, and that was been termed as earthquake weathercock. So what it comprised of was that it was a very beautiful, you can see here it is a very beautiful vase, and then you are having some 8 tods which are sitting at the base of the vase. So total like 8 dragons. Okay, these are the dragons here, and you are having the at the same time you are having also the tods which are sitting down. So you are having almost like 8 dragons are mounted around the vase, and with a bronze ball in the mouth of the dragon. Okay, so each dragon will have a ball, a bronze ball in its mouth, and then whenever there is a shaking of a ground, then the vase the bronze ball, okay, will fell into the mouth of the tods which are sitting here, okay, so with an open mouth. So that will help. So whenever there was an even a slight shaking, okay, or the earth tremor, a mechanism inside the seismograph, this is the what they call the weathercock, okay, would open the mouth of one of the dragon, okay, and the bronze ball would fall into the open mouth of the tods which are sitting down here, making enough noise. Okay, so when the ball passes through the mouth of the dragon and fall in, and it will make a very typical noise, okay, to alert someone that the earthquake had happened. So this is one of the very typical way to identify the earthquake, okay, that whether the earthquake has occurred or not in that area. So this was invented almost like 2000 years back, okay, as ago. So later on, lot many other scales came up, and we'll see the chronology of the intensity scale and all that first, and then get into the magnitude scale. Okay, so before 1931, earthquake intensity were often reported using Rusi-Fuller scale, and this scale was like and the last quarter again it was in 19th century, the use of the intensity scale become very widespread, okay, and this was basically dependent on the damage pattern and on there. Now this scale was been known as, because it was been modified by both developed and modified later on, then it was been known as the Rusi-Fuller scale. Now the most important part was that this came with the 10 folds, okay, so 10 degree of intensity scale was given. So if you take this, that was 1 to 10, it was been given. So this was until or you can say before 1931 the earthquake intensity scale was there. Then it was so this is, if you look at what it says, I'll not go into the detail of this, you can read out later on, but say like for example the intensity 1 means the microshock recorded by, either it is recorded by single seismograph if you have the instrument, still, because still you can use, and still we are using the intensity scale even though we are having the magnitude scale. So it says that it will be recorded by a single seismograph or of the same model, the shock felt by an experienced observer. Okay, so if you are extremely experienced to understand that whether this shaking was related to some earthquake or something else, then you will be able to make out that this was an earthquake with an intensity of 1. Intensity 2 is, it says, extremely fallible shock, and then intensity very fallible shock. So few people will be able to judge that there was some ground shaking. Okay, then 4 is fallible shock, then you can say shock of moderate intensity up to 5, so felt by everyone. Okay, so intensity 5 scale earthquake will be felt by everyone, and you will have disturbance of the furniture, beds and all that, and ringing of some bells. Okay, ringing of bells is like either we in India we say either the bells in the temple and all that, or in the church we are having the bells. So those bells will ring because there will be a motion of the surface. Fairly strong, that is 6, so on. Okay, so we are having like up to, you can say it goes up to 10. Okay, so you are having 10 intensity shock of extreme intensity, it says. Okay, great disaster, ruins. So most of the total damage will take place, and it says the fissures in ground. So land will have cracks which will be developed, and in the hilly areas there will be massive rock falls and all that. Okay, so this is how the intensity has been described. So you have this set of intensity scale. So locally you people visit, or the seismologists visit the to collect the ground truth, and then they assign that which area had what particular intensity during the time of an earthquake. Okay. Further, next phase came in. The scale was improved by Mercalli, who published a modified version, still with the 10 folds. Okay, so still we got the intensity scale of the 10-fold. Okay, however, even this 10 degree were insufficient for expressing the whole range of effects. Okay, so the extension of this scale came up within 12 degrees. Okay, so earlier it was 10, now it was been given by Kani. This they suggested that the more refined scale. Okay, and the reason was to express the whole range of damage. So that was been given with the 12 scale. Then this scale was been named as modified Mercalli. So first was Rusi-Fuller, then came the Mercalli scale, and the Mercalli scale was been modified by him, and then this was been termed as modified Mercalli scale with 12 degrees of this 12 degree scale. Okay, it came. So intensity, as we were talking about, that it measures it is the representation of the effects or the damage in particular area. So modified Mercalli scale, if you look at, it is also like mm scale. So it has been like bracketed 1 to 2 intensity, felt by very few people, rarely noticeable. 3 felt indoor. Okay, objects were disturbed, no damage. Then 4 to 5, we are having like 4 to 5 we are having felt by many people, objects were disturbed, but still no structural damage will be seen. And then some structural damage, that is from for 5 6 to 7 you are having damage, a little bit will be seen. And here if you carefully look at, then it says that the cracks in wall, high rise structures like buildings and chimneys. Okay, so this will be seen mostly. Then 7 to 8 felt by everyone, difficult to stand. Okay, so even so how you basically we try to know that whether this happened or not. Okay, so the seismologist or the geologist, when visit the area, affected area after an earthquake, they will also interview the people, okay, the survivors, and they try to understand that what type of shaking they felt and what type of damage they will record, that the damage that occurred during an earthquake. Okay, so based on this they will prepare a intensity map. I will come to that how the intensity maps have been prepared. Then you come to 9 to 10, major damage, collapse of weak buildings and cracks of strong buildings. Okay, so this is one. And then coming to 11 to 12, total damage or nearly total damage. So this will finish most of the damage or the area in terms of the damage. Okay, so this is very probably related to large magnitude earthquakes we talk about. Okay, so these are the intensity scales, and this is another like with the greater description given by USGS. Okay, and it was been given in 1974. This scale, which is again it shows up to 12, and with the greater description you are having, so you can go through this and then try to understand that what type of descriptions are given. Of course it is but difficult to remember everything, but you can look at the different type of descriptions which are been given related to the respective intensity. Now this is an example of the 1905. This was one of the massive earthquake in India. 20,000 people were been killed at that time in 1905. Okay, and this earthquake was of magnitude 7.8 and termed as known as Kangra earthquake. Okay, this occurred in Kangra Valley, and it killed almost like 20,000 people during that period. Okay, now if similar magnitude earthquake occurs in the present condition, then maybe more than 1 lakh or 1,50,000 people will be killed in the valley, because the population has gone so up. Okay, so this was what it shows here. If you can look at carefully, this all lines, okay, are having the some numbers which have been given here in Roman letters. Okay, so you have this one here, and this corresponds to this one here. You have, and then you are having higher intensity at Kangra. Okay, and then it goes to like, so this was again, it was 6. Okay, then you are having around it reduces to 4 to 5, and then further it reduces 2 to 3. Okay, so as you are moving away, this was an epicentral area. So as you are moving away from the epicentral area, you see that this intensity reduces. Okay, that means the damage also reduces. Okay, from away from that. So if you look at this one, this earthquake was felt almost in half of the Indian subcontinent region. Okay, so this is what is the intensity scale, and then this what we are looking are termed as isoseismals. Okay, so this indicates that all this region along this one, okay, had almost similar type of damage, okay, which they experience. So you can see that. Okay, so these are termed as this is very much similar to the contours which we see the topographical heights, but this is not the topographic heights, but these are the based on the similar pattern of damage which was experienced by along this region. Okay, so this is an example or the photograph which has been shown. So this was the damage of to the church by 1905 Kangra event, and this is during the earthquake, and this is after. So after it has been constructed, so you can compare this both the pictures which had been done. Okay, this is in Kangra area close to Dharamshala. So isoseismal map, as we discussed in this the previous slide. So you have like these are the numbers which have been given, but if when final map is been represented, it will be given with the Roman letters. Okay, so this is the epicentral area which has been marked here with the red. So it has an intensity of 8, but as you move away from this, it has an intensity which reduces to 7 and 7 to 6. Okay, so this is what happened. This is the intensity map. We are looking at the isoseismals of Bhuj earthquake. Okay, Bhuj 2001 earthquake. This again it was 7.6 MW, 7.6. Okay, so you can look at the maximum intensity was here. Okay, and then it slowly, if you move away from this, it reduced. Okay. So this is an isoseismal map of 2001 Bhuj earthquake. This is the same again. So this was an epicentral area which shows that the intensity was almost like 10, and then it reduced to 8, and further away, far away, almost like this. The distance from here to this was almost like 300 to 400 kilometers. Okay. So the intensity here was almost like 7, okay, which is comparatively very high. Okay, so 7 definitely it affected, and it resulted into a massive damage in this region. Okay, that is in Ahmedabad region. They experienced, and in Surat also they experienced, but Ahmedabad was been affected much more as compared to the other areas in this alluvial plain of Gujarat. Okay, so 300 to 400 kilometer away also it affected, okay, the region. So the intensity of 2001 Bhuj earthquake was almost 10, okay, in the epicentral area. This is an epicenter, the isoseismal map or the contours, isoseismal contours which have been shown for 2005 Muzaffarabad earthquake or 2005 your Kashmir earthquake. Okay, so again the intensity which came up to Patiala, Ambala or Amritsar was, or close to Delhi, was around 4. Okay, so the intensity was, so it reduced like that. Okay, so magnitude scale, if you look at, then several magnitude scales are widely used, and each is based on the measuring of specific type of seismic waves. Okay, so either you are, because if you remember, we have different type of seismic wave. We have body wave, PNS wave, we have the surface wave, love and Rayleigh wave. So depending on that, what type of seismic waves are been measured, the different magnitude scales were been generated and used. Okay. Now the first scale which was been extensively used earlier was the Richter scale, Richter magnitude scale. Okay, which is also termed as local magnitude. Okay, and it is denoted as ML. Okay, and then came the surface wave magnitude, which is given as MS, then body wave magnitude MB, and then you are having the moment magnitude MW. So this moment magnitude is now the most widely used scale amongst the magnitude scale. Okay, but still to some extent people have been using the Richter magnitude also, but this is very effective only up to 100 kilometers, and beyond 100 kilometers, that is if the seismograph is located or the earthquake occurs within that region where the seismograph is located within 100 kilometers, then this is more effective, otherwise it will not be effective as compared to the other scales. Okay. Then seismologists developed different methods to record the size of an earthquake, and based on the body wave which travels deeper within the earth structure, they came up with the body wave magnitude, and based on the surface wave, which primarily travels along the uppermost part of the earth, and they developed another scales. Okay. Now this is just to show that we have already discussed this part. This is the ML local magnitude scale. Okay, how in the previous lecture also we were talking about that if you are having the amplitude here, okay, and then from this zero line you are having the amplitude, and then you are having the arrival of the P and S wave. On the logarithmic scale you can have the what is the magnitude you can make out. Okay. So local magnitude can be recorded using the instrument which is known as or was known as Wood-Anderson torsional seismograph. Okay. So this instrument has limitations. This is what we are talking about, that it can only measure the local magnitude which are occurring up to 100 kilometers. Okay. So it has a limitation to measure the large magnitude earthquakes. The large magnitude earthquakes, when we are talking about greater than 6.5 or greater than 7.5 or so, okay, so then large magnitude earthquakes taking place at far distance. Okay, so if they are distant earthquake, then this instrument has limitation to record it. Okay, it gives very precise or accurate energy released by an earthquake up to 6.5 magnitude. Okay, however, locally it can measure the earthquake of greater than 8 magnitude, but if the distance is more than 100 kilometers or so, it will underestimate the magnitude. Okay, so the largest earthquake recorded was of 1964 Alaska. On Richter scale it was measured as 8.1, but it is greater than 9 magnitude earthquake. Okay, so this is what we have. Then the Richter magnitude scale. Seismologists use magnitude scale to express the seismic energy released by each earthquake. So if you look at the Richter magnitude, it says less than 1, less than 2 to 3.5, then it is generally what we consider this as a micro earthquake. Okay, so it will be recorded by the local seismographs, and then you are having the magnitude ranging from 3.5 to 5.4 or so, then often felt but rarely cause any damage. So very much similar to that scale which we were talking about the intensity, but this is in terms of the magnitude. Okay, so less than equal to 6, most slight damage, at the most slight damage will be seen to well designed buildings. Okay, then 6 to 6.9 can be destructive in the area up to about 100 kilometers or so. Okay, and then 7 to 7.9 major earthquake can cause serious damage over the large areas. Okay, and then 8 or greater, then we term that as an great earthquakes. Okay, so in the Himalaya basically we see the earthquake, or we observe the earthquake in 20th century were all great earthquakes. Okay, so modified Mercalli intensity scale and the comparison, I'll just quickly move ahead here, and then you can look at and compare that there is an intensity scale here and the magnitude scale here which has been given, and then comparative descriptions are been given for respective bracketing intensity and the magnitude here. Okay. So this is what, if you have an intensity of 11 to 12, then you are having total damage or nearly total damage of the area. Okay. So these are the seismograph which has been shown at USGS. So where you can see this small marks here, they are all the events, okay, which have been recorded. So this is the seismogram which keeps on recording the events. So even the smaller events are been recorded here. Okay, so continuous monitoring is done of the earthquakes which are occurring. So this is the same close-up picture of that one. And as we discussed during when we were talking about the igneous rocks, this is in the seismogram which is been from the Johns Ridge Observatory at Mount St. Mount Helens. Okay. Now limitations with the Richter scales were there, and then that was the reason that new scales to measure large magnitude earthquake, because if you are having large magnitude distant earthquake, the Richter scale will get saturated, or the instrument which is measuring the Richter scale magnitude was not enough. Okay, so new scales to measure the large magnitude earthquakes or the distant earthquake, teleseismic, what we call the far distant earthquake, were developed, and the first which the magnitude scale which came up after the Richter scale was the surface wave magnitude, denoted as MS, and then body wave magnitude MB. Okay. Now limitation again was there, which was been observed with the MS and MB scale. So surface wave magnitude, like if you local wave magnitude, we were talking about that it became saturated at 6.5, but this was the surface wave magnitude scale will become saturated at around MS, or almost like equal to 7.3 or so. Okay, and the body wave again about 6. So this again had limitations, both the scales. So in the new scale which was been developed, and it was thought that why not to take the overall deformation pattern, or the energy which has been released along the fault plane completely. And if you remember, we were talking about that along with the main shock, there will be small magnitude or micro earthquakes which will occur after the event, and which are termed as aftershocks, and those aftershocks are also taken into consideration to calculate the magnitude or calculate the rupture area also. Okay, so that is been given here. So you are having the length of the rupture, you are having the depth of the rupture, and then in short you are having the slip of the rupture. Okay, so how much slip occurred along the fault, how much what was the length and what was the depth. So if you are having these parameters, one can easily calculate the magnitude which was the newly developed. Okay, so Aki in 1966, okay, he proposed a new scale which was been termed as seismic moment. Okay, and then energy released, what exactly you look at here, okay, is the energy released or radiated from the entire fault is measured rather than assumed source. Okay, so anyways, we'll discuss this in the next lecture. I'll stop here. Thank you so much.